Alrighty, this is Trig lecture 9:30 and 10:1. In this case, the student will find the value of an indicated trig function. Again, we're going to be asked to find the value of a trig function given the value of a different trig function. And we're going to be doing much the same as we've done in the past. What we're going to do is construct a right triangle. I'm not going to worry about whether it's to scale or not. It's going to be a place that will enable me to put sides and angles, and that will enable me to find whatever it is I'm looking for. So I'm going to sketch, I'm going to draw my own figure, and then based on what I'm given, find what I'm looking for. So here we go. Let's see if this works. I want to find the value of the tangent of theta. I'm given that the sine of theta is 5 radical 7 over 16. So I'm going to sketch a right triangle. There's a nice right triangle. I'll label A, B, and C, and I'm not paying attention to scale. It's just a tool I'm using. Not worried about scale. And if I'm told that the sine of theta, here's what I'm thinking. If the sine of theta is 5 radical 7 over 16, then within the context of a right triangle, the opposite side of theta over the hypotenuse from a perspective of theta will be 5 radical 7 over 16. So I'm going to call one of these angles theta. I'm going to call this one theta. And I really don't need the A, B, and C here, do I? I think I'll just get rid of those. Since they told me of theta, we don't need A, B, and C. I can put theta anywhere I want in either of the acute angles. I'll put it right there. And then opposite over hypotenuse, opposite's going to be 5 radical 7. Hypotenuse is going to be 16. And I'm asked to find the tangent of theta, so I need the opposite over the adjacent. So I have to find this side. So I'm going to use my Pythagorean theorem. Remember that C is always the hypotenuse, and I'm going to call this A or B, it doesn't matter. I'm going to say A squared plus B squared is equal to C squared, and this has got to be C. So here's C. I'll call this B just for the heck of it. I got to call it something. And I'll say that A squared plus B squared is equal to C squared. And I know that A squared is unknown, because that's the side I need to find the tangent. So I'm going to say A squared plus B squared, that's 5 radical 7 squared, is equal to C squared, which is 16 squared. Okay? And now, I'm going to scooch this over and move this up a little bit, give myself a little bit more room. There we go. This will be A squared plus, that's 25 times 7. That would be, what is that, 175? Let me do that with a calculator to make sure. Yeah, 175. So, A squared plus 175 is equal to, I think that's 256. Let me go ahead and check that just to make sure. Clear. 16 squared is 256. Yeah. So now I'm going to solve this for A squared and then take the square root of both sides. I'm going to subtract 175 from both sides. And A squared will equal 81. And when I take the square root of both sides, I don't want A squared, I want A. I take the square root of A squared, I get A is equal to plus or minus radical 81. And because I'm talking about the length of a side, I don't have to consider the negative root. So I'm just going to ignore that. But it's true, within an equation, you'll get a positive and a negative root there, as we learned in Algebra 2. And so this would be 9, because we're talking about length, and there's no such thing as negative length. So now that I know that A is 9, I can find the tangent of theta, 5 radical 7 over 9. So that's what I'm looking for. The tangent of theta is opposite over adjacent. Okay. And hopefully that makes sense. We were given the value of a trig function. We said, hey, well, that's opposite over hypotenuse. Drew a triangle, made this opposite, that hypotenuse, I put the theta right there. Use the Pythagorean theorem to find the missing side, and then use the tangent of theta, the definition, to find the tangent of theta, opposite over adjacent. Okay. Let's take a look at another one. Find the cosine of theta if the cotangent of theta is 1. So again, I'm going to draw a little right triangle. I'm looking for theta, so I'm going to stick a theta somewhere. There's a nice place for a theta. And it says that the cotangent of theta is 1. Well, the cotangent is, let's see, adjacent over opposite. That's the definition of the cotangent function ratio. So I'm going to say that adjacent over opposite is 1. So I'm going to think of that as just 1 over 1. Or 5 over 5, or anything. 1 over 1 is the simplest. And I want to find cosine. So that would be 1 adjacent over hypotenuse. So I have to find the hypotenuse. So I'm going to use my Pythagorean theorem again. A squared plus b squared is equal to c squared, where c is the hypotenuse of a right triangle. So here we go. A squared plus b squared, just so happens they're the same, is equal to c squared. Well, 1 squared plus 1 squared, that's 1 plus 1. That's 2. I take the square root of both sides. I ignore the negative root because we're talking about the length of this side, so the negative root won't come into play because there's no such thing as negative distance. There's negative direction, but not negative distance. So c is radical 2. That's my hypotenuse. I got everything I need now. Whoops. There we go. All I got to do now is find the cotangent of theta, and the cotangent, the cosine, is adjacent over hypotenuse. So the cosine theta equals adjacent over hypotenuse. And we remember, hopefully we remember from algebra 2, that we don't leave radicals in the denominator. I'm going to rationalize my denominator by multiplying the top and bottom of this fraction by radical 2. And that will give me 1 times radical 2 is radical 2. The bottom of the fraction is radical 2 times radical 2, which is radical 4, the square root of 4, which is 2. So we no longer have an irrational denominator. We don't want that. And here's the cosine of theta, providing I haven't made any mistakes. I don't think I have. 1 over radical 2 is also the cosine of theta, but this is written so that the denominator is rational. We want to rationalize our denominators. Okay? And your calculator would do that. Most calculators these days will rationalize your denominator for you. Okay. Let's take a look at one more. Find the secant of theta if the tangent of theta is 15 over 8. So here we go. Once again, I'm going to draw a little triangle, ignoring scale. I'm going to put theta right here. The secant of theta is what I'm looking for. The tangent of theta, remember that the tangent is opposite over adjacent. So I'm going to say that's going to be, from this perspective, 15 over 8. I want to find the secant. The secant is hypotenuse over adjacent, so I have to find the hypotenuse. So I'm going to use the Pythagorean theorem again. A squared plus b squared will equal to c squared. So that will be 8 squared plus 15 squared is equal to c squared. And that will be 64 plus 225 is equal to c squared. I think that's 289 is equal to c squared. We take the square root of both sides. The square root of 289 is 17, and the square root of c squared is c. And this would be plus or minus 17 if we were solving an equation without the context. But since we're talking about a distance, a length, there's no such thing as a negative length, so we're going to ignore the negative root. So c is 17. Now I have enough information to find the secant of theta. Secant is the inverse of cosine. Cosine would be adjacent over hypotenuse, so secant is going to be hypotenuse over adjacent. So therefore I can say that the secant of theta is hypotenuse over adjacent, 17 over 8. If I haven't made any arithmetic mistakes. I didn't check my arithmetic with my calculator. Pretty sure I'm right. I hope that makes sense. Best of luck.